Hello everyone, I'm Janai and I'm an aerospace engineering senior student at CU Boulder. Right now I'm involved with the ecology and the evolutionary biology program at CU Boulder. I'm at a Smith lab right now, so we're going to do some cool stuff. Let's look at what's inside these two kits. First we have the body frame of the catapult, and we got paper plates, toothpicks, glue, ping pong ball, and rubber bands. Couple of the rubber bands. So first we're going to cut the body of the catapult, and then use the toothpicks and the paper clip to make sure the catapult stands still and firmly stand on the desk. And then we're going to attach the rubber band as a spring of the catapult. And the last step is to use the ping pong ball work as a stone or weapon on the catapults. Today we are going to build a catapult. The catapult is a military weapon, and we think it was invented in China over 2,000 years ago to use in the war. If you have played the game Angry Birds, probably remember the catapults that you can use to shoot birds at their enemies, and maybe you thought about what determines how fast they go. Just like the catapult we are building today, the speed is determined the energy generated by pulling back the rubber band. Pulling back the rubber band creates the potential energy, which is the P in the formula you see on the screen. And the potential energy turns into the kinetic energy, KE, the energy of the motion when you let it go. How fast the bird or any object you should travel depends on how stiff the rubber band, which is the little K in the formula, how far you pull back, which is the little X, and how heavy the object is, which is the little M. At the bottom you can see what we get the most speed when we pull back the farthest. When our rubber band is stiff, and when our object is not too heavy, good thing the birds are not very heavy. Okay, so now let's start. So this is our catapult. Maybe you can try to build yours if you have time.